Thank you. Welcome everyone. Good afternoon. So I'm going to try and entertain you about interfacing QGIS from R, from the R programming language. Some of the other contributors were figured on this slide, and I must say that a very international contributor team in this package. So all the people mentioned here are already each from another country. So my involvement in this project is rather recent. I work at the Research Institute for Nature and Forests in Belgium. And there I'm helping with other colleagues, of course, to aid scientists in their work using R in data science and analyzing data sets. So we foster open science a lot, and I would like to thank also my employer to support our work in this and for me to come here and present this to you. So we contribute to open source applications, of course, and recently I became the maintainer of this QGIS process package. Dewey Dunnington from Canada, he has really created a package. So with other contributors we have been adding other functions, and so now I have accepted to maintain this further. So the R community, I'm not sure how well presented they are actually at this conference. Perhaps I could just ask the question, who has already used R? Perhaps raise the hands. Wow, that's quite a number, that's good. So you know it's free and open source, it's cross-platform, so it's an easy-to-learn interactive programming language. It can do data manipulation, can do a lot of different calculations, visualizations. It's very good at computing, and especially it's well known for its built-in statistics. So the base R installation has numerous functions built in to make statistical models. And therefore it has strong ties to scientific research. So if you look into science in the papers, you will see that R is used a lot. Many R packages evolve from the scientific community. There are almost 20,000 packages now on CRAN, which is the comprehensive R archive network. That's the major official repository for R packages, although there are still several others. And of course, there are also quite a few packages to represent, analyze or visualize geospatial data. A few of these, SF and Terra, are quite popular nowadays to represent vector and raster data. There are also stars, and there are still others. For the visualization, there are also quite a lot. I just named two here, which are used often. It's MapView and TMap. And you can get a larger overview of these on the CRAN website, which is a well elaborated page. So why would we interface QGIS from R in the first place? Of course, you can guess it is because you can expand the geospatial processing capabilities of R while still having and keeping the other advantages of the R processing functions. By remaining in R, you gain more reproducibility because you make just a script. You have everything in there. You don't have to jump forth and back between different tools manually, so to speak. So you can really reproduce your whole workflow, and that's a really strong point, especially for in the scientific contexts. It is needed. Even you don't need to create a QGIS project to use this. So it's really aimed at the processing capabilities and the processing algorithms. Moreover, since QGIS has access to many other backends like GraphGIS, Saga, Google, but I could have added several more like Whitebox tools and PC Raster and Orfeo Toolbox, etc. There are many, many plugins available to do specific processing. Well, that makes it an easy entry to access them all. Of course, that doesn't mean that you cannot access several of these in a separate way. So, for example, GraphGIS has an rgrass package to access it explicitly and to take more control over what grass can do. So there are several powerful tools anyway besides of QGIS, but this is really an interesting entry. It is also not new interfacing QGIS from R. There have been in the past several packages already, but they have ceased further development because of various problems, and also they needed to work around through Python, the Python API, which was not that easy always to maintain. But since a couple of years, there is a new possibility because there has been a QGIS, does this work? It's hard to see, I can't see it. It's the QGIS underscore process executable, that's a shell command. So it's perhaps a little bit confusing because the package is called qgisprocess without the underscore, but so that standalone qgisprocess command allows to access all the algorithms that are in this way exposed. And so it doesn't need to the setting of QGIS environments, which the older packages needed, and it's actively developed, of course. Besides QgisProcess, there is the QGIS package. Also, we will see later what it exactly can do. So the command line, QgisProcess executable, it takes several parameters, and it's just a few examples here. You can say QgisProcess run, give the algorithm name, and pass parameters like input layers and stuff. It can also, that's a second form, take standard inputs, which must then be a JSON string, and get it like this. It can enlist plugins, it can do things with plugins, so just to get flavor of this. So the current packages, QgisProcess is a direct interface to the executable QGIS package. Builds on top of QgisProcess. It provides numerous functions, one function for each algorithm. So it is dependent also on the actual QGIS version that you have installed, because yeah, it takes that current list of algorithms. But it has its advantages its own way. Let's take a simple example. Let's suppose we have the Sene dataset from the SP data package, and let's suppose we want to sample points at a regular distance along these lines. So we can load the R package like this, library QgisProcess. It tells which QGIS version is going to be used and how many algorithms are available according to the currently enabled plugins or processing providers. So we give the path to the data set. We can already have a look in R what is in the data set. So you see 3 rivers enlisted in it. So now we run the algorithm, and the main function is QGIS run algorithm. So so here it takes the Sene path, the file, as an input, and you say, well, we want to sample. It's the native points along lines algorithm, and we tell it to sample every 10,000 meters. So for the algorithm, the parameters that we didn't pass, it takes default values. The alternative with the QGIS package is to just take the function which corresponds to the algorithm. So what we did is assign it to a result object, and Result object, it is actually a list of several elements which can be handy to debug, but also it contains, of course, an output element which is typically a path to the resulting file, and we can extract it with this function directly, which takes as a default the output element, the element that is named as output. So there's the result. We have the points along these lines. There are other convenient functions in the package, like which algorithms are available that correspond to a certain regex string. For example, the regex points, etc., and then line. And then we can get some algorithms. So that could be a way to find potential algorithms that we could have used in the example. You can also search on provider. There are several arguments actually in this function. You can list the currently available providers, the currently loaded plugins, the currently loaded algorithm. I don't show all the but some useful ones. You can retrieve the documentation within R for the algorithm. So it gives the description, it gives the arguments, so that you can know how to deal with them. Speaking of arguments, it's good to know that you don't always have to just pass strings as would be needed for the command line. You can actually use R objects and pass them, so that is supported. There is some sort of conversion involved. So, for example, for the spatial argument types that QGIS needs, for example, the vector layer, you can pass an SF object or a terra object. For the raster layer, there are also several supported object types. The multilayer can be fed by passing a list, an R list actually, and same for several other object types. And this is also true for non-spatial argument types. For example, you can provide a data frame if you need to pass a matrix QGIS input argument. So the left column, these are really the QGIS input argument types. So that has been provided more recently. An example here is that when we load the library, the R package terra, we load a geotiff file, we assign it to the LF object. We can see it is a spot raster object, and now we can run an algorithm. For example, it's we requested statistics and we just pass LF as input. We don't have to refer to any file, which is especially handy when you have already processed something in R and actually only have it in memory, the thing that you want to pass. Extracting elements from the result, we have already seen this. QGIS extract output, extracts by default the output element. It has a file path, but there may be other elements or outputs involved in an algorithm. You can just request which ones an algorithm does provide by using the function QGIS get output specs. In this case, it's a graphs algorithm, r.flow, and it says it will provide you a flow accumulation, a flow length, and a flow line output. So if you want one of these into R, you just need to specify, oh yeah, it's a flow line that I need. Further on, so we had a result object. The result object contains, for example, the output element, but you can just skip that step even when you want to convert to a spatial R object, because the output element just contains a file path. Then when you use the SF package, you can just pass it the result and it will extract the output element and read it into an SF object. In case it is not named as output, of course, then you have to say, okay, I need flow line, and then pass it to SF in this way. Similar functions have been written to convert into terra, raster, stars objects. as well. There's more. You can use these things in piping contexts. For example, let's say that we want not only to sample points along these lines, but also we would like to make a buffer around these points. So we can start again, we do it all over. We start with the Seine file path, and then say we want to do points along lines. But you see here, there's a underscore P. This is because this function is really crafted for using in pipelines. So it's this is because a pipe. This is the pipe character. So Seine, without further ado, it goes into the first argument of these functions. So the function is designed specifically for usage in pipes. So, but for the rest, it looks the same. In case the second step, where we will make a buffer around these points, in case it would not, by default, it takes the output element. That's what I want to say. And in case it needs something else, you can pass it. In that, you can give an argument, select another object. That is also specific to this piping type of function. You can also use the QGIS functions in a pipeline, but you have to extract the output before you pass it to the next one. So because these are still the same functions as we used before, they are not really specifically made for doing the same. So we created buffers. Let's jump to the QGIS GUI. That's also an interesting aspect, which has been developed in QGIS about more than 1 year ago, but still very recent. What you can do, you can play with the algorithm, of course, and that you would like to tune, and so you provide some settings. In this case, we already have the buffers, so that's our input layer here, the 1 kilometer buffer around the points, and we want to do some zonal statistics. So we take the zonal statistics algorithm and we pass some parameters. We can try it out, of course, in the GUI, but anyway, even without doing that, we can copy the settings as a JSON string, and so the QGIS run algorithm function does accept that. So the JSON string looks like this. It has the parameters that the algorithm needs, and like this, you can pass the JSON string. So it gives back again QGIS output vector element, which is a file path again to the results. So we can take that vector. It's still the polygons of the buffers, but we can here extract what we really need, statistics about, in this case, elevation data within these buffers. And well, we do some data wrangling, and then we have this result, which we can, of course, in R then further process and make simple graphs. In this case, for example, you can do many other things as well, of course. But this is just to illustrate how a workflow could look like. The package has some online documentation, so the functions, well, I could click, I think. So for example, you can see they are organized according to the workflow that you would normally use, and they also have description of the arguments, more information, and some examples. So like this. Oh, I was too fast. So the same holds for the QGIS package, where we have also this type of description. One important advantage of the QGIS package is by having these algorithms as separate functions, is that the arguments from the QGIS algorithm documentation actually are present here in this website and as well in the R help documentation for these functions. There is also a cheat sheet with most of the information I have given here already. For future developments, we can still add more tutorials. For example, for these subjects, we can expand still the function documentation here and there. And of course, we try to follow up extra features that the qgisprocess executable would gain. I would like to thank all the contributors to the package. It's a very nice and friendly community. As you can see, there is still room. So more people are always welcome to help and to join, but it's very nice to collaborate with these people. That's it. So I want to thank you for your attention, and if there are